Pamela Markham and Alexandria Nell from the GTM Research Reserve.
Hi, good morning. My name's Pam. My co-biologist Allie and I are going to be presenting on 10 years of marsh monitoring and wetland monitoring here in the Research Reserve. So to jump right into it, what are wetlands? Wetlands are land that gets wet. At high tide, they flood, and at low tide, they drain back out. And here in the GTM, we have two types of estuarine wetlands. We have salt marshes pictured on your left and mangroves pictured on your right. The goal of our monitoring is to evaluate change over time. So we need to collect a lot of data over a long period of time, which is long-term monitoring. We have two ways that we look at this. And the first way is to look at the entire expanse of the marsh. So from the edge of the water all the way up to the dry uplands. And that's our shore to upland transects, which are the red and yellow dots on the map. The other way that we look at this is just the edge of our marshes. So from the edge of the water to 10 meters in, and those are the black dots on the map here. Now this edge zone is very important because it's the interface between our open water habitats and our marsh habitats, and the species that live there and the physical properties in those two different habitats can actually mix and interact there. So today we're going to focus our presentation on this marsh edge monitoring. Now, this monitoring was made possible by a partnership between the National Park Service and GTM, and we identified 6 locations throughout the reserve to install some platforms for this monitoring. And the platforms allow our researchers to easily and safely access these sites without inadvertently impacting the sites by trampling on that marsh. So at each site, there are 3 platforms, and they have a series of plots that are installed around the platforms that we can go back to that same place and take the same type of measurements over time. Today, we're going to focus on our vegetation monitoring, which is the squares with the V, and our elevation monitoring, which is the circle with the R. Now, Allie will talk a little bit more about elevation in a minute, so I'm going to jump into the vegetation. In 2012, we started our vegetation monitoring. We go out in the spring and in the fall, and we collect data on which plants are there, the species of plant, how much of those plants occur, and how tall they get. So diving straight into that data, we can see that in our northern and central portions of our monitoring, we see that the marshes are dominated by Spartina alterniflora. In Pellicer, we have a Juncus marsh, and in Washington Oaks, we have our Baetis marsh. The biggest change that we've captured over time is the presence of the black mangroves, particularly at our East Creek and Washington Oaks sites, where you can actually see the mangroves are increasing at those 2 sites in recent years. So what this is telling us is those 2 sites are actually transitioning from salt marsh into mangrove wetlands. Another big thing that we've noticed over time in our monitoring is the loss of one of our species, the Salicornia ambigua, the one in yellow. In areas where we saw it present in the early years of our monitoring, in more recent years, it's declined or even disappeared from some of our sites. Now, looking into how tall the plants get at these sites, at our northernmost sites, Pine Island and Hat Island, the Spartina is pretty consistent throughout the monitoring. We're not seeing a whole lot of change there. But if we go down to East Creek, where they're transitioned into mangroves, not only are we getting more mangroves, they're growing larger over time, but conversely, the grass there, Spartina, is actually declining in height, so it's getting shorter as well. In the southern portion of our reserve at Moses Creek, we also see this declining trend in canopy height of the Spartina, particularly in recent years, it's getting shorter and shorter. At Pellicer Creek, we're seeing fairly stable canopy heights, and the dips you see are generally associated with large weather events. In our Washington Oaks site, again, we see the mangroves are getting larger, but here the Spartina is also getting larger. So it's a little bit different dynamic than what we see at the East Creek transition site. So in addition to physical measurements of the vegetation, we're also capturing an additional form of change in our marsh edges, and that's in the form of marsh edge loss. So the plots that were at the very edge of the water at the beginning are highlighted in red in the diagram. And this graph is showing the number of those plots, or the proportion of plots that are still there today. So over time, we've lost about half of those plots due to erosion. So one of the marsh edge loss that we're capturing is physical loss in the form of erosion. And we see this a lot at our Moses Creek site, the one in the middle. So we can see that we've actually lost about 3.5 meters of marsh due to erosion at this location, and the creek itself has started to widen. Another form of marsh edge loss we get is seen at our Washington Oaks site, where we're not seeing physical loss in erosion, we're seeing vegetative loss. So the vegetation is actually receding inland about 3 to 3.5 meters at this location. So the plots are still there. There's just no plants growing in them. So our monitoring design is to capture change over time, and we're seeing that. So we're seeing things are changing as time progresses. And we can use the vegetation change as an indicator of something bigger that might be happening. So the vegetation is very sensitive to the physical factors in these environments. So if we see large scale or rapid changes in our vegetative communities, we can then look at those locations and say, okay, something's happening here. Maybe we need to investigate a little further about why it's happening, because our monitoring is about what, not why. So one of the things we can look at is the water quality. And if you were here yesterday, you heard a lot about nutrients and high nutrient loads in some of our waters. So if we see high nutrients, this actually can destabilize some of our marsh creek edges, and it allows higher rates of erosion that would naturally occur, and then the creeks widen. So in areas where we might see higher erosion or widening creek, this might indicate to us maybe we need to add some additional monitoring in our water quality and see if maybe nutrients are affecting that area. Another major issue in coastal systems is sea level rise. So how does that affect our marshes and our vegetative community? And can it tell us something that's happening? Well, as the sea levels rise, that the wetlands that are supposed to be exposed to air at low tide are no longer exposed. The water can't go anywhere, it's too high. So then the plants there start to drown and die off. And then you get this migration of the vegetation, or that edge of the marsh moves inland. So in areas where we start seeing this migrating marsh, we can then say, all right, maybe something is happening here that we need additional information, particularly as it applies to sea level rise. This is also a really important aspect in general, and to determine how our marshes are comparing with sea level rise, we need to understand the elevation of the marsh. So when we look at the coastal wetland as a system, we need to know rates of change. And if those rates of change are keeping up with each other, so if sea level rise and the rate of elevation change are keeping up together, then we understand that our marshes are doing okay, they're keeping up. But if our rate of change of the elevation of the marsh is not as high as our sea level, then we have an issue here. The plants can drown out, we can get changes in our community, it starts to fragment and break up, or it could completely be lost altogether. And so this can indicate some changes we need in our habitat management goals as well, if we start seeing changes in our vegetation community. So the key thing here is that we have rates of change: sea level rise rate of change, elevation rate of change. And so to understand what the physical factors are affecting our marshes, we need these rates. So the first thing we can look at is sea level rise. In Jacksonville, Mayport Station, their National Ocean and Atmospheric Association has a tidal gauge there that actually monitors for sea level rise. And for our region, they see a 2.76 millimeter increase in sea level for our area. So now we have that rate of the sea level. Now we need to figure out our rate for our marsh elevations. So to look at that, we need to actually measure elevation in the marsh. So again, that's going to let us know, is it stable? They're keeping up with each other, our marshes are doing okay. Or is it not keeping up? And now we have areas that we're a little bit more concerned and need to look at a little more closely and focus. So to do this, we measure the elevation, but it's a kind of hard thing to do because there's a lot of different things that affect the elevation of our marshes. And that's kind of the take home of this diagram I have here, is just to show you there's a lot of processes that affect our elevation really at any given moment in time. So from hour to hour, that elevation can change. If we get a huge rainstorm, the marsh might swell up and change our elevation. If it's been really dry for a while, it might shrink and contract back down. If there's a lot of plant growth, it might shove the surface up higher. So a lot of change means we need to be able to find a pattern when it's going all over the place. So to see the pattern in all of that variation, we need long-term monitoring. So we actually have to see what's happening over time. And fortunately, that's part of our monitoring. So Allie's going to let you know how we track that monitoring of elevation over time.
Awesome, thank you, Pam. As mentioned, my name is Allie Nell. I'm the co-biologist here at the GTM NER. I'll be talking to you about the elevation portion of our vegetation monitoring. So we look at elevation through two different lenses. We have broader scale change and finer scale changes. And we have this permanently installed rod that is present at each of our platforms that Pam went over earlier. Now for our broader scale changes, we attach this GPS unit to that rod and it collects centimeter accuracy GPS points at each of our platforms. We couple this with the leveling data that is shown to the right here, which involves just popping over to each of our plots and collecting 5 data points within each plot. And that kind of offers us this bigger picture of what the elevation is looking like at each of our sites. Now, this graph here that we're seeing is illustrating one sampling event. The boxes all represent all of the data points collected at each platform for each site. The black line in the middle is the median measurement, and the red dot illustrates the average measurement that is collected at that platform. Now, you might notice a lot of variability between the platforms at each site, and this is likely due to these outlying data points that we're seeing over here. One more thing I'd like to draw your attention to is at the very far right, our 2 most southern sites have a fairly low elevation relative to the rest of our monitoring sites. So keep that in mind for later points. Now moving on to the finer scale changes, and we're going into a little bit more detail about this data. And that is because we've been doing this for quite a while. We're approaching 10 years, which is crucial because it does take about 7 years of data collection to really begin to notice any patterns or trends in the elevation data that we're collecting. So once again, we're utilizing this permanently installed rod, and we are attaching the SET to it. Now, SET stands for Surface Elevation Table, and it is a portable leveling device shown to the right here, disassembled. When we attach it to that rod, which you can see our very own Scott Eastman installing at one of our platforms, and it allows us to revisit the same little patch of marsh sampling season after sampling season to measure the relative gain or loss in elevation at those particular points. Now to do this, we orient the SET arm to face the same direction as it is faced in past monitoring events to really make sure we're getting to that same location within the marsh to measure. We lower these pins of known length until they rest on the sediment or really on the interface, so hovering just above. And then we measure the distance from the SET to the top of those pins to get our elevation points. Now, before I jump into the data, I want to orient you with the graphs that we're about to be looking at. The blue line is indicative of it illustrates the change in marsh elevation. So we're not looking at raw data points here. We're looking at the change over time since that first pin drop in 2013. And the red line is the sea level rise that Pam had touched on in the previous slide. So it's going to have the same slope in each graph. It's just going to look a little different because of the different range of values that we're seeing in marsh elevation. Now the graph to the left is an illustration of a marsh keeping up with sea level rise. We want that blue line to have a similar slope or an equal slope or a greater slope than the sea level rise. I do want to point out, it doesn't matter if the blue line is above or below that red line, we really are just looking at the slope. Now the graph to the right is a picture of a marsh elevation not keeping up with sea level rise. So notice how while the blue line is increasing, it's not increasing at the rate that we really like to see. So starting at our northern sites, we have 2 platforms in Pine Island that have that nice slope where it's increasing quicker than sea level is rising. We do have one platform where that's not necessarily the case. While it is going up, it's not going up quite quick enough to keep up. Now, a similar story to that can be told at Hat Island. We do have one platform that's increasing, just not quite quick enough. And then one platform that's looking pretty abysmal. You see a loss in elevation at platform C, but fortunately that's not really too indicative of the health of that marsh because there is a little pool that has been expanding into the range of the SET pins. So that's just kind of this little pool that was in the middle of that site, kind of over to the side of the SET and just kind of encroached into that range.
1 minute.
Now moving on to our middle sites, you do see a nice increasing trends at all of our platforms at East Creek, and we think that that has a lot to do with the increasing mangrove population that we see at that site. Moses Creek also has a nice marsh gain, which is interesting considering Pam had shown that the increasing or the loss of marsh or the increasing creek bank. And we haven't quite started to see that yet in our SET readings. So stay tuned for that. Our southern sites are looking a little less great. We have one platform in Palliser Creek that is gaining elevation, but not quite quick enough. And then 2 platforms are actually losing elevation. In Washington Oaks, we have one platform that is keeping up with sea level rise, and we again think that may have something to do with an increasing mangrove population at that particular platform. So I'm going to pass it along to Pam to wrap us up. Thank you so much.
So what we see from our monitoring here is that the edge of the marsh changes a lot. It's a very dynamic environment, but it can be sensitive to physical changes to the system. So by understanding what's happening on the marsh edge, it can indicate what might happen to the rest of the marsh itself over time if we don't intervene or identify issues that are affecting it. These are extremely important ecosystems because they help protect our lands. They're a buffer zone from storms, storm surge, excess waters. They soak up a lot of nutrients and that excess water, and they're critical habitat to the organisms that live in this system. So by understanding the patterns that we see over time, we can then identify areas that are of more concern than others and focus additional research and identify needs for those areas that help us inform what is happening here, why it's happening, and then adjust any management that we need for these systems. So with that, I'd like to thank you guys for your time today, and then we will take any questions.
Awesome. Thank you so much, Pam and Allie. That was a wonderful presentation. We did have some questions come in. Our first question is, could you explain why high nutrient levels can maybe exacerbate erosion in our marshes?
Yeah, so generally in salt marshes, what happens is the roots of the plants, particularly Spartina marshes, they actually start searching for the nutrients which are stored deep down in the sediments of your marsh. So they start digging really deep, far down, and they actually kind of mesh and get all entwined with each other. And that holds the marsh together. The roots are kind of like stakes holding the marsh together. When you have extra nutrients available in the water, they don't have to go searching deep down for those nutrients anymore. It's basically delivery to their door. So they don't have to go searching, and the roots start to get less shallow, and they're not as kind of structurally sound as they would be, and they can't hold together that sediment anymore, and things start to collapse.
Thank you. We had a comment and then a question. So one of the slides on the changes in the marsh edge down at Washington Oaks showed some features that maybe looked like bare ground near the upland ends of the platforms back in 2011, which seemed to have been maybe replaced by vegetation in last year in 2021. Have you seen this on the ground at the sites, and can you comment on what the changes might be at that site?
Yeah, so can you guys scroll back to that picture so we can see it really quick? This one. Okay, so what you're seeing, the brown is actually the water and the green is the land. So the 2011 picture, what the difference in colors is actually the plant community is what you're seeing in here. So at the edge where the double platforms are, so the bottom of the picture, it's mostly Batis back there with a little bit of Spartina, but in 2021, it's mangrove now. So the color variation isn't that we're seeing bare ground, you're just seeing a different type of vegetation, and that's just the color signature from the satellite imagery.
Great question. Can you speak to the pattern of loss and gain causing a drop in elevation around 2018 at many sites that most seem to have bounced back from?
Yeah, so when you look at the scales, these are millimeter change. So some of these drops, they seem kind of exacerbated in these graphs because it's a tiny, tiny scale. 2017, we did see Hurricane Irma come, and we had a lot of flooding. And so our 2017 measurements could have had a little bit higher elevation from original, and then it just dropped really low in 2018 after everything dried back out. But I don't really know exactly why that drop is, but if we see it across the board, it could be a hurricane impact from the year before.
Great. Thank you so much for those questions and for the responses to those, Pam, and wonderful presentation. Thank you.
Thank you, everybody.